Alright, let's wrap this week's lecture. So, I believe you have learned a lot of things in this lecture, and if you actually go through all of those things, I believe you will have a very profound basic on MATLAB. Okay, so in this week, we have learned how to write a function by ourselves, a user defined function. We have also seen how can we create a function with variable input arguments. Okay, then we have performed some string operation with, in particular, that is the regular expression. That's a very interesting feature of any programming language working with string manipulation for string manipulation. And another one in particular that I have shown you, that is called binary image representation. Okay, and inshallah in the next week's lecture I am going to get into a bit details about image processing, okay, and plotting as well. Now, before we actually finish, I want to clear some of the confusion that you might have. Okay, so first of all, that is called the vectorization, and some of you may ask how the vectorization is actually working and why it is actually working very fast. Okay, so let's take a look. I have shown you these things in our lecture 1. Okay, this vectorization in lecture 1 or 2. So this was the non-vectorized approach. Okay, and this was the vectorized approach. So as you can see in the time difference, so when I'm writing this non-vectorized, I get like 5.16 seconds, and when I'm writing this vectorized way, I am getting this small amount of time. The question is how it is actually working. So when I'm writing this explicit for loop, and what is the difference with not writing that way. Okay, so let me give you a brief idea, okay, a concise but brief idea about those things. So for example, I have like something this way. Okay, let's make it, instead of 7, let's make it 2. So I have this short array, for example, okay, just to work out these things. So I am trying to figure out how many maximum element is there, how many number of maximum element is there. So the maximum element is 6. I want to count how many are there. So I can actually write a for loop like this way. So write a for loop like this way, go through from first element to the last element and check whether it is the maximum element or not. Okay, so this is the for loop approach. Okay, this is the for loop approach. I will go from one element at a time. I'll go from one element, check it is a maximum or not, then check again, then check, I'll find one, this is a maximum element, so increase the count by one, then again check, no, then again check, yes it is true, then increase the count, and something like this way. But when I was writing this vectorized way, so I was writing something like this, that x is equals to max of x. Okay, I was creating a logical array first, then I was just thumbing through all of those things. Okay, something like this. If you don't remember this, please go through the last week's lecture a little bit, this portion only. So what does it do? Why does it actually, for a long array, like for 6 or 7 elements, that's completely fine, you are not going to understand the difference. But when you have a element of 100,000 or 1 million or few millions data, this is a must. Okay, you cannot use this for loop approach. So why is that? Now try to understand what we are actually trying to do when we write a vectorization. We try to tap into the processor's power, your laptop's processor power. Again, when I'm actually writing this vectorization, I am tapping into the processing power of the computer. Okay, let's see how it actually works. So what I actually I was writing here when I was writing this, I was writing a for loop for I is equals to say 1 is to say dot 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 dot, this bunch of elements. Okay, all of these elements, something like this. Then, okay, in the next line, I was providing an instruction, something like this, and this was int, say for example like this. So what it is actually doing, it is going to take the first element, look at the first element, okay, then perform this operation, this max operation that I am actually trying to find, whether x is equals to max, this if is condition, this operation. It is going to perform this operation on the first element, okay, then again loop back, go to the second element, perform the same operation again, then again loop back, go to look at the third element and perform the same operation. That means, so I have this processor, say, think of this is our processor. I am going to feed in this instruction one at a time. I am going to feed in this instruction, writing a for loop through this way, giving one element and uh, performing this operation, then feeding another element in performing this operation, one operation at a time. But try to understand, our processor has a very high power. Okay, our processor, computer's processor is very high functional, so it can actually work with multiple amounts of data at a single amount of time. Okay, again, our processor can work with huge amount of data in a very short period of time. Okay, but when I was working like this, I was actually feeding it only one element at a time, and I was performing an instruction then again. So I was just one giving it one by one instruction like this way. But instead of doing that, what we are doing it here is that I have the same function. So I have this same array, but instead of feeding it one by one, I am feeding the whole element altogether inside this processor. And that most important, I am not feeding the instruction one by one. I am not saying it to perform this instruction one by one. Rather, I am providing the instruction once. I am just saying that perform this instruction on all the elements. Perform this instruction on all the elements. That means I am not providing one instruction at a time, one by one. No. So if you start counting from 1, 2, 3, 4, 5, 6, 7, 8 like this way, counting from 1 to 1 million is a huge amount of time. But instead of doing that, this processor can already take this amount of data. So I am just providing one particular instruction, okay, and saying to the computer that perform this instruction in all the elements. So it only depends on how much fast it can actually operate, or it can actually process this actually data. If you have a 100,000 example, that is no problem for a computer, because it has a very high processing power. The key feature is I am not providing this instruction one by one. Rather, I am providing instruction only once at the beginning, and it is going to perform this operation. So this is what is called actually this portion is called SIMD. That means actually single instruction. Okay, single instruction. This is what is called single instruction, multiple data. Okay, try to understand. So single instruction means I am going to provide only single instruction on all the data all together, not one by one, but all of them all together. So this way we can actually tap into our processor's power and operate much faster. And this is actually a must operation. This is actually must when you are working with huge chunk of data. Okay, so I believe it should be clear now. And the second thing that was the string. Okay, let's take a look at another one. Some of you was having some problems with the strings. There is two types of things. That is, one is called character array, and another is actually string. Okay, and let me actually clarify these two things. So say for example, if you compare these two, 2,4,9, okay, and 249, okay, this is something I actually use. So when I'm writing this, so similar to that, if I write a character array like, I have a character array like this, A, B, C, okay, and if I have a string like this, A, B, C. If you are working with older versions of MATLAB, if you don't cannot do this, that's completely fine. Try to understand the concept, because string is actually a very powerful tool for MATLAB. It is actually makes it very convenient in many scenarios. So you can actually compare these things like this way. This 249, when I'm creating an array like this, these three are actually individual elements. 2 is a single element, 4 is a single element, 9 is a single element. Similarly, when I'm writing this character array like ABC, this A, B, and C, they are actually individual elements. This is not a whole thing. Okay, this is not a whole element, rather individual elements. Okay, but when you are writing like this 249, as you can see, this is not this is not three elements, rather this is a single number, 249. You cannot actually get inside these things. Okay, this is a one thing. This is a atomic, we actually call it atomic. That is the proper way to call it, atomic. Okay, similarly, when you are actually working with this string, this ABC, when you use this double quotation, that means this is actually atomic, same to this thing. this ABC's whole thing as a string. Okay, you cannot actually get inside the individual A and B and C. No, this is actually whole thing in all together. Okay, so these strings have some particular application, okay, different applications that you will actually notice only when you actually practice lots of things. Okay, so I believe you actually understand the basic difference between these two. Now the last thing that I want to talk about is what is called toolbox. Okay, you may have already noticed when working in MATLAB. So for example, there is a function that is called next prime. I have already written those things in the lectures. So as you can see, there is something that is written as symbolic math toolbox. But if I write something like this, is prime, but it is written as MATLAB. So that is what is called actually when in programming world we can actually do lots of things are actually happening. Okay, now this is something that is called the base of MATLAB. Okay, think of it that is the base. Okay, now there are so many things that are actually happening all the in the world. There are so many tasks that we can do. If I put all of those things in the basics of MATLAB, in the base of MATLAB, then the software will already become very bulky. Okay, so it cannot be put in that way. So what is actually done, something that is called the base of MATLAB. On top of that, there are different toolbox attached to it. They are additional toolboxes. These actually toolboxes perform some additional tasks. For example, signal processing toolbox performs signal processing tasks. Image processing toolbox performs image processing tasks. This individual toolbox actually provides different functions that are actually necessary for this particular task, but these are not included within this, the basics of MATLAB. But these are actually built on top of these basics of MATLAB. So if you want to work in these things properly, understand, okay, you need to understand the basics of MATLAB very clearly. Okay, that is actually very important. Otherwise, they are actually then these toolboxes function. There are many functions. They actually tap into this. Okay, different what I can say, different interesting features of MATLAB. Exploit those features of MATLAB. Built on those things, they have actually created these toolboxes. Okay, so you don't have to worry about those things now, just to give you an idea what actually it means. Okay, when you actually encounter many functions, you will see some of the functions I am writing, you will be using toolbox function. But one thing is that sometimes this toolbox function may not be available because these functions are added each year. Okay, so if you're using 2 years old function and 2 years old version, then one of the toolbox may not be available in your MATLAB. Okay, that's one thing. Similar to that, like for example MATLAB, if you start with Python, you will see in Python we call this actually module. Okay, Python also have some basic Python functions. Additional to that, okay, based on top of it, there are different modules or libraries. Say for example, like NumPy, that is the most widely used part, like NumPy. Then you have Pandas. Okay, then you have Kraken. Okay, then you have OpenCV. Okay, then you have OpenCV, or you can say Matplotlib. Okay, Matplot library. There are many other libraries are there. They actually performs some particular task. They actually required for a particular task. For example, this OpenCV work for image processing task. The Matplotlib actually used for plotting tasks. So different separate tasks actually that can be performed just using this library. Using the Python programming language, I can just use these additional libraries. Okay, these are also work with Python programming language. Okay, similar to that. So you can understand the vastness of the programming world. There are so many things. So using these separate libraries, we can actually perform separate tasks. Okay, so I hope it is clear, and let's finish it.